going to complete the square over here on the left. Everybody remember completing the square? I told you it'd never go away. It's going to come back. Even like put up our friendly little CTS poster over here. I want to complete the square. Anybody know where I should start?
Add the 5.
No, I can do either of those things. I'll start with adding the 5. And then I'll divide everything by 4. That gives me y plus 5 over 4 equals x squared plus 6x. Now what? Yeah, my b value is 6. So if my b value is 6, then b over 2 is 3. And b over 2 squared is 9. So I'm going to add a 9 over here, and add a 9 over here. Now, we've never done them before with a y over here. That's what's new about this. We've never done it with a y before. We've always had a number. So we haven't really seen this action on the left before. This is all kind of new. But it's going to work out pretty intuitively. Y plus 5 over 4 plus 9. And over here, this right side can factor. What does it factor into? Yeah, x plus 3 squared. It's always going to be x plus b over 2. Whatever this number is, that number is always going to go in that spot. X plus b over 2 squared. Well, I want to get the y by itself, so I'm going to subtract the 9. Multiply everything by 4. Subtract a 5 from everything. And then I get y equals 4x plus 3 squared minus 41. I've completed my square. Tell me what I know about that equation now.
It's in a form.
It's in a form. Good. What else? Yeah. I could graph it. By looking at the equation, what do I know about the graph?
It's going to open up.
Well, what kind of graph is it in the first place? Start there.
A parabola.
It's a parabola. Because this is being squared, we have a parabola. It's opening up. How do you know that?
Because the a value is positive.
The a value is positive. It's 4. What else do we know? Where's the vertex?
Negative 3.
-3, -41. It's in vertex form. That's the point, is the vertex. Okay. We're going to do a lot of completing the square in this chapter to find vertices, which makes graphing things possible. I'm going to do this same problem another way. 4x squared plus 24x minus 5.
Standard
The book is going to call one of these standard form and one of them general form, and I think that's stupid. I'm not sure which is which. Right now, we've been calling this standard form, but I think the book is calling this general form. The point is I'm going to put this in vertex form. One thing that I can do is take this -5 and just sort of push it way off to the side. Leave it out here. And instead of dividing everything by 4, like we did last time, I can factor out the 4. Then I can do my b over 2 squared. And I can add a 9 here. And so if I add a 9 to one side, I have to add a 9 to the other side. But what's very confusing about this, the reason some of you aren't going to like this other method, is I didn't really add a 9. I really added a 36, because it was 4 times 9. I really put 36 here, so I have to put 36 over here also. I added 36 here, and add 36 here as well. That's going to give me y plus 36 equals 4 times x squared plus 6x plus 9 minus 5. This can factor. Y plus 36 equals 4 times x plus 3 squared minus 5. Subtract the 36, and I get y equals 4 times x plus 3 squared minus 41. Same thing we got last time, but different method. I don't care which method you use. I think this method I just showed is much faster and much easier, but a lot of people get lost when they forget to add 36 to both sides. A lot of people lose sight of that part of the process. As with everything in math, The easier way of doing things is usually the harder one to understand. And whichever one has more steps takes more time but involves less thinking about what you're doing. Is there a question about that at all? Yeah.
Are like all, I want to say all problems, but most of them, would they be able to be like factored like how you did this?
Yes. It won't always be nice and clean and pretty like this. Sometimes a fraction somewhere, but everything can have a completed square if there's a square somewhere to begin with. You can complete any square. Any other questions? Okay, let's go back to that second problem that I had. How should I start this problem on the right? First of all, do you want me to do it the first way I did it or the second way? If you care. I'll do the second way. I'm going to move that -1 out there. So I have this thing sitting out over here. And I'm going to factor out a -1/3 right now. And when I factor out a -1/3, that becomes y squared minus 12. I did 4 divided by -1/3, and 4 divided by -1/3 is -12.
Negative 12y.
Y, thank you. Okay, my b value is now -12. So b over 2 squared, b over 2 is -6, so b over 2 squared is 36. I'm going to add a 36 here, and add a 36 here. 36 last time too. Oh, see, I just made the same mistake. I made the mistake that I'm telling you not to make. I didn't add a 36 here. I added a -12 there. Because 36 times -1/3 is -12. Added a -12. Yeah?
Can you explain the step again when you got -12 from 4?
I did 4 divided by -1/3. And 4 divided by...
that one and you times...
Now look over here. I did 24 divided by 4 to get 6. That's what factoring is. You're dividing. So if I do 4 divided by -1/3, 4 divided by -1/3 is the same as 4 times -3, because you multiply by the reciprocal of that.
Oh, I see what's happening.
Yeah. Let's stick here. So, now I have x minus 12 equals -1/3. This in here can factor into y minus 6 squared minus 1. So it's x equals -1/3 times y minus 6 squared plus 11. I added that 12 to both sides.
Is the 12 always going to be so the thing that you're adding is going to be the same as the middle term? Or is that just...
No, did it happen both of these times?
No, actually no.
Yeah, just happened on this one. It happened on the green one. Other questions? How is this graph going to look? The graph of that equation. What's that equation going to look like? Yeah?
6, whatever.
Nope.
Well, the y's not, but so.
Good. Look, this isn't a y equals. It's an x equals. We haven't done this yet. This is new. As you're going to see in just a few moments, this is going to be a parabola on its side. It's not actually a function. It's a parabola on its side. That's what we're learning about today.
We can do this in our calculator, can we?
Not the way it's written. There's other ways to do it. Yeah?
So would the vertex be 11,6?
Oh, that's a great question. The vertex is 11,6. Very good. Because that's still the y coordinate. It's next to y. That's the point. That's the y coordinate right there because it's next to y. That's the x coordinate. The vertex is 11,6. We'll get there. We'll talk about that. We've talked about parabolas and their properties quite a bit, actually. And I even put back up my parabola poster. The vertex is the highest or lowest point. The axis of symmetry is the line that cuts the parabola in half. We know that all parabolas are symmetric. We know they have those weird curves to them. We've talked about how they model gravity. We'll learn a few really interesting things about them today. The new things we're going to talk about are called the focus and the directrix. The focus is really just some random point. It's not really random, it's a point. And the directrix is a line. I'm going to jump over to Sketchpad. Here's a parabola. Yes, Annabelle?
Is there a reason why we didn't learn these things when we first?
Too much. Just too much, too fast. There's kind of this building that we're doing, and this is going to be our last chapter before Trig, that kind of like bridges the gap between them a little bit in a couple of ways. So yes, would have been too much to do the quadratics with all this back then. Here I've got labeled a focus, a vertex, and a directrix. Okay, so if I pull this focus up, you can see how the parabola changes. The vertex is that point on the parabola that we've seen before. It's always halfway between the focus and the directrix. The directrix is this line right here. And there's a couple really interesting properties that happen with parabolas. If I have, I'm going to construct a perpendicular line here. If I think about like a ray of light coming in here perpendicular to this directrix, when the ray of light hits the parabola, it gets reflected to the focus, wherever that ray of light is. If the light comes in here and hits that parabola, it'll bounce right there. And if light comes here and hits the parabola, it'll bounce right there. So when you see a satellite dish, or when you have, like at a football game, they have those microphones that have that little like half bubble around it, it looks like a semicircle. It's actually not a circle, it's a parabola. It's called a parabolic microphone. And it collects everything that's sent into it and sends it to the microphone. So it's like this would be your dish. That's that little weird ball you see kind of floating in the middle of the dish, because everything gets collected by the parabola and bounced into that focus. And that's how a parabolic microphone can get a really clear sound of what's happening far, far away, because all that sound gets collected in one spot. It's actually like really interesting, I think at least. And if you live in warm climates or sunny climates, you can have parabolic microwaves that collect all the sun and gather all the sun that it can into one spot, and you can heat things up very quickly. Not quite as fast as actual microwaves, but like in a minute and a half, you can get something pretty hot without using any actual electricity. It doesn't work in Oregon because we don't have enough solar for that. Another really interesting thing about parabolas, this is really what a parabola is. If I take any random point on this parabola and I connect, oops, I wanted to keep that perpendicular line, and I make this point here, I'm going to draw this segment here, and I'm going to hide that line that I had behind it. If I measure the distance of this segment, to measure its length, it is 6.86 centimeters. If I measure the distance from here to here, well, I'll connect the segment first. If I measure this length, it's the same. And wherever this side moves, these side lengths are the same. A parabola is every point that is the same distance from the focus to the directrix line. All these distances, focus to J and J to K, are the same. It's actually like the main idea behind the construction of a parabola. That's sort of how we discovered them.
What could that be used for?
That in and of itself, nothing. But that's how you make a parabola, and that's how the parabola is used for things like satellite dishes and parabolic things. Yeah?
So, in the past we graphed just the problem, so are we going to have to graph directrix?
Focus and directrix, yeah.
Stuff?
And we're not going to worry about so many points along the parabola itself. Actually, we'll usually just do 3 kind of quick points on the parabola, and then the focus and directrix are kind of the key for this unit today. So let's go back to our smartboard. To recap what we just talked about, a parabola is the shape that is found by finding all the points equidistant from the focus and the directrix. The directrix is just a line, and the focus is a point. If you were to pick any point in a parabola, it would be the same distance from the focus and the directrix. That's a restatement of the first line. And the vertex of a parabola is halfway between the focus and the directrix. The vertex is always halfway between. I can move the focus down closer, and that makes the parabola really narrow. I can flip it upside down, and I can make it really wide and really flat. But the vertex is always halfway in between. This is on page 623. there's two types of parabolas that we're going to look at. One is a y equals, like we've done before. The new one is an x equals. Y equals, like I said, since we've done it before, we're familiar with how they work. We know where h and k is as the vertex. We know the AOS is the line x equals h. Finding the focus and finding the directrix is the new thing. That's what we'll spend most of our time on today. If you have an x equals, where the y value is being squared, if the y value is being squared, then the parabola points left or right. If the a value is positive, the parabola points right. If the a value is negative, the parabola points left. And then this is the important thing. Notice that h and k have switched. H is on the outside, k is on the inside this time. Because h is always the letter we put with x. K is always the letter we put with y. K is a y coordinate, so it goes with the y value. I will leave this up for a second and kind of talk through it as you're copying it down, but it's also in your book, and it'll also be online, of course. The weird thing is this k plus 1 over 4a, or this h plus 1 over 4a. To find the focus and find the directrix, we do a little computation that involves a reciprocal function with an a on the bottom, and then we calculate it and graph it, basically. It's just going to be some simple arithmetic, but this will seem very confusing at first, and once we get some time behind it, it'll be okay. It's going to be very foreign at first. Is there a question before we move on? Yeah?
What are the commas in the focus?
The focus is a point. No, x and y. Like h and k has a comma, it's a point.
Gotcha.
That's a point right there.
So,
Whereas the directrix is just a line. That's why it's y equals or x equals. So I'm going to keep scrolling up and down and referring back to this. But we are going to graph this equation together. X equals 2y minus 4 squared plus 1. If x equals 2y minus 4 squared plus 1, I can grab all of that. I'll leave it like that for now. What type of parabola is this going to be? It's going to be sideways. Is it going to point to the right or point to the left? How'd you know it was sideways? It was x equals, the y is being squared. So that's this one, these ones go sideways. And how'd you know it was going to go to the right? The a value is 2, and if a is positive, the graph goes to the right. Just like how here, if a is positive, the graph goes up. So I'm going to write down that equation, x equals a times y minus k squared plus h. And like the most helpful thing is to start by figuring out what a, h, and k are. So right now, what's a, what's h, and what's k? A is 2. Well, y is negative. K is actually just 4. K is 4. H is 1. Because of this negative here, we take the opposite of the k value. So here it looks, since it was y minus k, well, k would be 4, so that y minus 4 would be the negative 4. Let's see what I know. I know that my vertex is at the point hk, which is 1, 4. I know that my AOS is going to be the line y equals k. Is that right? Yes, y equals k, the AOS. So that's y equals 4.
and for the other one, it's the ALS is y equals 8. Right?
X equals h.
X equals.
X equals h, y equals k. The focus. Okay, the focus involves me doing. So I'm flipping down so much. H plus 1 over 4a, comma, k. Well, that's h is 1. A is 2, K is 4. It's looking confusing the way I'm writing it right now. I'm going to go 1 plus 1 over 8. That's really the point 9/8, comma 4. Do a little calculation. Plug A in, calculate it. It's 9/8, comma 4. I'll pause there because the focus is new. Is there a question about how I did that? Okay. Finally, let's find the directrix. To find the directrix, I do x equals h minus 1 over 4a. It's going to be 1 minus 1 over 8, which is 7 over 8. So the directrix is the line x equals 7 over 8.
So is the directrix always horizontal?
No, depends on if the graph is going sideways or up and down.
If it's sideways, then it's horizontal. If it's up and down, it's vertical.
If the graph is going up and down, if the graph is going like this, the directrix will be here. And if the graph is going like this, the directrix will be there. It's an x equals, and x equals lines go up and down. Yeah?
Is there a reason on the focus where you didn't put the 1 with the 1/8?
Well, yeah, 1 plus 1/8 is 9/8. Right, so the 1
Oh,
plus 1, it's h plus 1 over 4a,
and then you.
and I actually put them together. Yeah, 1 plus 1/8 is 9/8. Uh-huh.
So would the directrix ever go diagonal?
It can, we aren't going to. It is possible, but we're not going to mess with it. It makes things substantially harder. Okay, I'm going to graph this now. My vertex. So here's the thing. Graphing points that have these fractions, like 7/8 and 9/8, I don't want to be counting by 1s on my x-axis anymore. In fact, on my x-axis, I'm going to count by 8s. On my x-axis, I'm going to count by 8s. So I'm going to go 0, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8. But on the y side, I have to get as high as 4. So counting by 8s wouldn't really make any sense. So on the y side, I have to go to 32/8. I don't want to count up 32 of these. So I'm actually going to go like 1, 2, 3, 4. I'll count by halves just to give some space. And then what do I have? I have a vertex at 1, 4. 1, 4. This is the point 1, since 8/8. 8/8 is 1. My AOS is the line y equals 4. You don't need to graph the AOS, but I think you're going to find it helpful for framing your graph in the beginning. Eventually, we probably won't worry about it. This right here is the line y equals 4. That's my AOS. My focus is at the point 9/8, comma 4. Well, that's here. That's the point 9/8, comma 4. That's my focus. And my directrix is the line x equals 7/8. I haven't even graphed a parabola yet. All I've done so far is put down one point, the vertex. It's the only point actually on the parabola so far. But now I have an AOS and a directrix and a focus to work with. Now here's the trick that I'm going to explain millions of times over the course of this chapter. The distance from the focus to the directrix, the blue line, is 2. That's a distance of 2 units. Well, I can take that distance and go up 2 and down 2 from the focus. And those other 2 points are on my parabola. There's 2, so up 2, down 2. Because that means the distance from here to here is both 2. Distance from here to here is both 2. Now I'm just going to go curve that thing out as best I can. And that's my parabola. Question there. Yeah.
This might be a silly question, but is there ever like an asymptote for a parabola, or does it always just get bigger and bigger?
That is not a silly question. There's not an asymptote. It's always going to hit whatever value it wants. I mean, obviously it can't hit anything over here,
Well, yeah.
but that's not the definition of asymptote.
Right.
Yeah. Any others? Okay. We're going to write the equation of the parabola with a focus at 2,8 and a directrix with a line x equals 6. You don't have to do this with graphing. You don't need to graph to do this, but you're probably going to find it really helpful if you graph. If the directrix is the line x equals 6, here. Well, if I go 1, 2, 3, 4, 5, 6, that's this line right here. That'll be my directrix, x equals 6. So I already know that the parabola is either going to go this way or this way. The parabola points away from the directrix. Well, now what? Sure. Focus is at 2,8. So here's 2, 1, 2, 3, 4, 5, 6, 7, 8. There's my focus. 2,8. Now what?
You go 4, 4 on one side because it's, or 2 on one side.
Can it break in 4, 8?
Yeah, it would be 2 down and 2 up. From the
Right.
right.
If this, you guys are saying different things for the record. If this is the point 2,8, we know the vertex is going to be halfway between these two, so the vertex is at the point 4,8. That's my vertex. And now, he could tell you saying anyways. He's saying we can go, if this distance from here to here is 4, I go up 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. I can get my parabola from that T. So we at least know that it's pointing to the left. So we could have figured that out without graphing it this far, but that's okay. But I wasn't asked to graph it. I was asked to find the equation. We have graphed it, and that's probably going to be helpful in finding the equation, but we still have to actually find the equation. What form is this equation going to be in?
X equals.
X equals, so it's going sideways. I minus k squared. We're going to find A, H, and K in this parabola. Well, do I know any of those? Uh-huh.
A is going to be negative because it's pointing to the left.
We know A is negative because it's pointing to the left.
H is 4. And K is 8.
H is 4, K is 8. That's H and K. So now we have this. I can say that A is negative. I'm just going to leave A the way it is. I just want to make sure when I'm done, A is negative. Good. How do I find A? Now, how come? There's 3 variables. But you could run with that a little bit, Lindsay.
Oh, you did conclusion.
The square is already complete. Anybody finish Lindsay's thought about how we could solve for A? Sure, Joe?
6.
The Directrix isn't actually part of our graph at all. The Directrix is how we constructed the graph, how we built it, but not actually part of the parabola itself.
By itself?
Well, we still don't know what x and y are, so it doesn't help us very much. Sure, Chase?
Would you find the slope between the point and the original?
It's a good idea, but no. It's a hand-drawn graph, and there's not really a slope of a parabola. You want to finish your problem?
Well, I was just thinking, since you know what the focus is, could you use the focus since you know what your H is and your K?
No, that's a very good idea. The problem is the focus isn't part of our graph. That's not actually on the parabola. The parabola is just this here. But we do have a point there.
So you could use a
I could use that point or this point up here, which I can't see on my graph right now. But I could grab the point. That's 2, 8. That's 7, 6, 5, 4. This is the point 2, 4. I could plug a 2 in for x, and a 4 in for y. I can solve for a. And this is actually a very easy process. A is negative 1 over 8. And like Chase said, it's going to be negative. The fact that it is negative here is a good thing. We end up with y equals negative 1 over 8. X equals negative 1 over 8.
8.
And here's our equation. Given just a directrix and a focus, we can find the equation. If I gave you a focus and a vertex, or a focus and a vertex or a directrix, any two of those three things we can solve for. What's another way that we could have found A? We have H and K pretty easy. What's another way we could have found A? I like showing multiple ways so you can pick the one you like and run with it. Our directrix is the line x equals 6. But we know to calculate a directrix, we do this. H minus 1 over 4a. But I know that x is 6, and that h is 4, and I can solve that for a. So I get 2 equals negative 1 over 4a. Multiply both sides by negative 4a, and I get negative 8a equals negative 1. Positive 1, I guess. Divide both sides by negative 8. A equals negative 1 over 8. You can also do it that way. That way wouldn't require any graphing. You could theoretically do all that without graphing. Okay, question there at all?
Is it like best to graph this to find them out?
Yeah, I do. Yeah. Unless I've been doing this for a while, where I've just got a good feel of how focus, vertex, and directrix all relate to each other, and I can find distances in my head, I generally do a graph and just look at it and go from there. Other questions? Maybe this will be our last one. Yeah. This will be our last one. Turn to a friend, tell your friend how this problem is going to look. Ready, go.
That's smart.
I can't wait to watch this video on YouTube and just hear Annabelle talking about her abs. Cannot wait. What fun. Annabelle, how's this graph going to look?
Pointing up.
Pointing up? How do you know?
It's still recording.
How do you know it's pointing up?
Because it's positive and it's y equals.
It's y equals and it's positive. The a value is positive, so we know the graph is pointing up. This is not a new graph for us. This is an equation we have graphed, or equations like this we have graphed many, many, many times. The only new thing here is going to be finding the directrix and the focus. The vertex is where?
Negative 14.
Negative 2, negative 4. Because we're doing this.
So if it's x, it's opposite.
Right. This is one we've seen before. Yeah, Joe?
How come it's less than 0? How come it would be down? How come it's pointing up?
It's about positive, negative. It's not less than 0. It's less than 1, but it's positive. It's about positive, negative. Come on, we have a question. Did you get it answered? A question of some sort. Awesome. Okay, what is the directrix? Or we'll do the focus next. What is the focus? Well, we have to go back to our table. I will give you this stuff on quizzes and tests. Okay, I'll give you a handout that'll have all this information on it. So don't try and memorize it. Or don't bother memorizing it. Huh? Yep. So we are doing this one here. Y equals k minus 1 over 4a.
Why is it 4?
Minus 1 over 4.
I'm doing the focus.
Yeah, we're doing the
Not the
focus.
directrix.
That's what we're-
Right. That's Directrix.
Yeah, we'll just do the directrix then.
Say that.
My bad. Do the directrix since I wrote k minus 1 over 4a. Yes, why is it 4?
Yeah.
I will try and answer that question later, like next week. It is not an easy question to answer. But if you think about the quadratic formula, it has that 4 also, minus 4ac.
Yeah.
It's kind of because we're ultimately squaring a 2 in the process. The squaring of the 2 comes from that number, and the 2 kind of comes from the symmetry of the ideas. But that's basically it. It's just sort of like the algebra works out to a 4. So, y equals k is 4, negative 4. I'm going to do a is 1/3, h is negative 2, k is negative 4. Writing out a, h, and k first is so helpful. I'm going to do negative 4 minus 1 over 4 times 1/3. How do I deal with that mess of a fraction? By what? The reciprocal. This is why we talked about our fractions before. It actually simplifies to that. Multiply by 3 over 1, instead of dividing by a third, multiply by 3 over 1. You get negative 4 minus 3/4. Ooh, I'm sorry, negative 4 minus 3/4. Negative 4 minus 3/4 is negative 4 3/4. That's my directrix. Let me find the focus. Focus is h comma k plus 1 over 4a. H was negative 2. K is going to be negative 4 plus 3/4. Which is negative 2 comma negative 3 and 1/4. Now, I've got vertex, directrix, focus. And my page just gets messier and messier and messier, but I'm trying to keep track of what's going on here. Graphing these quarters isn't going to be super easy, but counting out 19 quarters, like 1, 2, 3, 4, 5, 6, 7, 8, I can't even fit that on my plane the way it is right now. So kind of the nice thing about this is you sort of have some control over your graph. I'm going to take the middle of this graph, that point right there, and I'm going to make that my vertex. So I'm going to make this the value negative 2, and this the value of negative 4. I'm going to build my graph, my plane, around the vertex. Well, the directrix is going to be negative 3 1/4. Negative 2, negative 3 1/4. So that's going to be, so I'll do like negative 4, negative 4.5, -5, -3.5, -3, -2.5. I'm basically counting by quarters now.
Going back.
And here, well, I'm going down. Like the origin would be like up here.
Oh,
And I have my y-axis going down and my x-axis going this way. Yeah?
So this is kind of a stupid question, but even if you're going by like different increments than just by one,
Mm-hmm.
you can still do like 2, like 1, 2.
Yes.
So like -2, -3, and so if you don't have to count by according to like by what you're going to, you can just do like.
Well, I am.
Two down.
I'm counting by quarters right now. I'm just showing every other one. Like that's -3, -3 1/4, -3 1/2, -3 3/4, -4. So I'm counting by quarters.
But like no matter what like scale it is, you can always go just like 1,
Mhm.
2.
Mm-hmm. Okay, so that's my. Mm-hmm. I'm not doing lines right now, so I'm not worried about slopes. And the reason we tried to keep the same scale before was because we had lines. Yeah. Directrix, y equals -4 3/4. That is this line right here. It's my directrix. Focus, -2, -3 1/4. So here's -2, and then here's -3 1/4, right here. So this is my focus, this is my vertex. Let's graph this in blue. This distance here is 6. I'm going to go 6 over this way. 1, 2, 3, 4, 5, 6, and put a point there. And 6 over this way. 1, 2, 3, 4, 5, 6, and put a point there. And then through the vertex, I have my parabola. So that T isn't really part of it. It's just how I actually construct it.
Can we do the T?
Yeah, I'm begging you to do the T. The T is the way to do it.
Do we have to erase it?
No, I'm just trying to keep it clear with what's happening. But maybe that'll be less clear later on.
I have a random question.
Okay, is it about your abs? Okay.
So can you put the directrix and focus in your calculator as a program, and then what's it called?
You can write a program to calculate them, yes, but there's not like a way to have your calculator just do it right now.
Yeah, that's what I mean. Like,
Yes,
right.
and that wouldn't be terribly hard to do.
Like, would that be a good idea, or would it?
I think it'd be a good idea to both know how to do it and have the program if you want to write it.
So you gotta write the program for a little while.
Yeah, I would wait a couple days and then write it once you know what's going on. Yeah?
so I'm not sure how you went from y equals -4 minus 1 over 14 to the third to y equals -4 x.
You're talking about this right here.
Yep.
Okay. I'll put on a new page. -4 minus 4 1/3. Well, not quite. That's what we had. Okay? Well, that's really this. Right?
Yep.
And really, think about the last chapter we just did.
Oh, that's multiplying with 3/4.
Pardon me?
That's like multiplying.
And you can just do that in your calculator. You can type this into your calculator and then do the answer frac thing and get out that fraction. Yeah. Answer frac.
I don't know if I-
Press the math button. Because I can just show that.
Oh.
Like we've done it a trillion times, Katie.
We do quick. We have to be fast.
Katie, you're playing games right now, is that what you said?
No, it's slightly quick.
So it was
Math. Frac. I see frac.
-4 minus 1 divided by, and this will have to be in parentheses,
Are you doing programming now?
1 divided by no. Do I want that? Yeah. You might want to do it in stages, not do it all at once like I just did. You could, do 4 times a third, 1 divided by that, -4 minus that. But you can get it on your calculator.
So if you were to just have like 2 parentheses at the end, they wouldn't mess it all up.
I think so. This right here is the part that's going to get ruined. That 4 times 1/3 has to be in parentheses. So I think I could have done this. -4 minus 1 divided by parentheses 4 times 1 divided by 3. Yeah, that's the simplest way I could have written that. And then arrow frac, it's not going to give you the whole number, but it's going to give you that. Okay, questions about that at all? Finally, your homework when you do your graphs. I want you to label the focus, label the directrix, label the vertex. That doesn't mean just write directrix. I mean literally write the equation of the directrix. Right, the vertex is the point 2, -2, and the focus is the point 2, -1. You can always find your t if you want your t. The t is there to be had also. But why don't you start working on homework, and I'll come around and check off the last 2 assignments and video.